we'll proceed in the gradient vector area, and we would kind of do some volume calculation. So we will proceed in gradient vector area, and we will calculate kind of volume. So idea is that we calculated gradient vector. If I have a position vector, if I have a position vector, then if I have a position vector, then from position vector we calculated the gradient of it. What we did? So if I have a position vector, then from position vector I calculate gradient. Position vector means if I take any point on the surface of a kind of object, 2D or 3D. In 2D we saw one circle. In 2D we saw one circle. In 3D we saw one sphere. Okay, so if I take any point on the surface, and from center if I draw a line, that is a position vector. If that point is x, y, z, understandable, right? So if I have a surface like this, consider this is a ball, sphere, football, soccer, and this is the point on the surface, that is P. It is centered at the origin. So from origin, if I draw a line through P and pass it, then this is a vector. This is a position vector because it passes through origin. If that is the case, since position vector P has coordinate x, y, z, then this vector has is xi plus yz plus zk. P equal to xi plus yz, xi plus yj plus zk. If that is the case, then dp by d, or rather say, if I calculate gradient of it, gradient of it. So gradient means derivation. dp by dx, dp by dy, if it has two independent component x, y. If it has three independent component, dp by dx, dp by dy, dp by dz. Okay, so if it is a single dimension, then it will be xi plus yj, where y is function of x. Mind it, y is function over x, like y equal to square root of a square minus x square. This is equation of a circle. Z equal to square root of a square minus x square minus y square. This is equation of a sphere. This is calculus way, where you have independent and dependent components. Here the independent components are x and y. If that is the case, then z equal to square root of a square minus x square minus y square. If that is the case, then position vector P equal to xi plus yj plus zk. Z I can replace with square root of a square minus x square minus y square. If I calculate dp by dx, dp by dy, I get two vectors. One is in along x-axis, dp by dx. One is along y-axis, dp by dy. If that is the case, then if I do cross product, then it resolves into xy plane. dp by dxi, dp by dyj. If I do cross product, it will result in independent component as xy plane. So it is as good as dp by xy plane, dp by dxy plane. If that is the case, whatever I get, that is called velocity surface vector. If I calculate the magnitude, then it becomes velocity magnitude, velocity magnitude. If I integrate it along the xy plane, then it gives me surface area. Now we calculated surface area. We calculated surface area in Cartesian coordinate, in polar coordinate, in spherical coordinate, Cartesian polar hybrid model, Cartesian spherical hybrid model. Clean sweep. So we did everything to finish it off so that it will be more in circulation, more in culture. This, the way we are doing, can we calculate volume of a sphere? So that is the question that we are kind of thinking. Volume of a sphere. Okay, so I really have I really have one sphere. Okay, how nice a sphere it is, I don't know. I have bigger sphere. Okay, this is one sphere and this is another sphere. Okay, so we will calculate volume of this sphere. It looks like a sphere, right? So volume of this sphere. So what would be the volume of this sphere? That is in question. I mean, there is a better sphere. This is really a sphere. Okay, so volume of a sphere. So that is in question, but I'll hold it because it is small, it is too heavy. What is volume of this sphere? Okay, what we have discussed till now, how to calculate volume. What is integration? Integration is nothing but surface area. If this is x-axis, if this is x-axis, this is x-axis. If this is x-axis, then I have function over x. I have function over x, that is fx. So this is a line that is function over x. Fx is nothing but height. So if this is fx, if this is fx, this is x-axis, then at every x, fx is height. Can you see this? If I say fx that is the height into x, then it gives me this area. If this is a flat line, consider this being a straight line. If, if this is a straight line, consider this is a straight line parallel to the x-axis. If I calculate the area fx into x, x is width and fx is height, then it is rectangular area. But if it is anything that is not straight, then in abstract fashion, I can say this area is nothing but fx, that is the height, into x. Fx into x. In calculus way, it is fx dx. Limit, lower limit, higher limit. Lower limit means x equal to a and higher limit is x equal to b. Between x equal to b and between x equal to a, whatever the in between area you are seeing, this is the area, lower limit and higher limit. Now if I say I have fx, very nice. If you have fx, just integrate it fx and you will get the underneath area. I have xy plane, this is xy plane, this is origin. I have xy plane. If you have xy plane, then there is a surface. If you have xy plane, there is a surface. Surface means it is fxy, function over xy. Fxy is nothing but vertical. At every, in previous case, at every x we have vertical. At every x comma y is in 2D. At every x comma y we have fxy, that is z, that is vertical. If I connect all the point, it becomes a sphere. What is the volume of the sphere? So if fxy is the height and independent component being 2D, earlier independent component was x, here independent component is xy plane. If independent component is xy plane, If independent component is xy plane, then fxy, integration of fxy, that is the surface, instead of a line that is a surface, integration of fxy would give me volume. If it is xy plane as independent component over xy plane, if I have a surface, one limit to other limit, if I integrate this surface, the down of the surface is volume. fxy dA, fxy dxy plane. Earlier we had fx dx. Here fxy dA dxy plane will give me volume. What is fxy for sphere? X square plus y square plus z square equal to a square. Z equal to a square minus x square minus y square root. Z square equal to a square minus x square minus y square. Z equal to square root of a square minus x square minus y square. If that is the case, then I can place it here. fxy dxy plane, that is one single integration. Now fxy is turning up into square root of a square minus x square minus y square, and dxy plane turning up into dx dy. Why it is? If I take xy plane, this is x-axis and this is y-axis, then at any point if I take a small area region, then it is area region, that is rectangle, because xy plane is rectangular, because x-axis is like this and y-axis is like this, then it forms a rectangle. If I take a small rectangle, if I take bigger rectangle, then it is x into y. Then a small rectangle is dx into dy. So now I have fxy d area. fxy is z, that is square root of a square minus x square minus y square, and then d area is dx dy. This is what I have to integrate. Limit is x. Now if it is a sphere, if it is very heavy, it is like one kilogram. It's very heavy. It is very heavy, like iron. See God's creativity. We believe that we are so creative in our life. God make like this as million and billion daily basis. Okay, and if you cut it and see through microscope, then you will see how intricate it is. How powerful God is. Anyway, now if I pierce this, then, and this is the side that is touching left side, and this is the side that is touching right side, and if this is the origin, center, it is centered at the origin, then radius of the sphere is a, then it is minus a and it is plus a. So the xy plane we are talking integration fxy dx dy. If I break this integration sign into two, double integration, then x starts from minus a to plus a, y minus a to plus a, fxy dx dy. fxy is this fxy, dx dy is xy plane, this. If I integrate fxy function, that is the surface, along xy plane, it will give the volume of this this God gifted. Okay, so that is the concept. If that is true, let's proceed on. Square root of a square minus x square minus y square dx dy. Let's proceed with dx first. If that is the case, then a square root of a square minus x square minus y square would turn up into square root of a square minus y square minus x square. Consider a square minus y square as constant. This is our formula. Whatever we are going from talking, whatever we are talking, all are disclosurable, and we will place disclosure on it. That how to calculate volume through primitive calculus. Through primitive calculus. Okay, you can support us. You can support us. Phone number you know. You can let us know. 94831 60610. You can text at this telephone number. Country code is 91. India. 94831 60610. You can support us. Okay, anyway, now if I kind of if I'm trying to calculate square root of a square minus y square minus x square dx dy, I'm just leaving it dx. Now a square minus y square I am considering as constant. Now consider x equal to square root of a square minus y square cos theta. Square root of a square minus y square cos theta. If this is x-axis, this is origin, and this sphere is centered at the origin. If this is x-axis, and this is origin, then a sphere is centered at the origin. This is minus a, this is plus a. Consider a radius here, and it is moving like this. Radius is square root of a square minus y square, and this angle is theta. If this angle is theta, then a square root of a square minus y square cos theta is x. Consider x equal to a square root of a square minus y square cos theta. Dx equal to a square root of a square minus y square minus sin theta d theta. Let's substitute it. So we have square root of a square minus y square minus x square dx dy double integration minus a to a minus a to a. Square root of a square minus y square minus x square would change into, in bracket we can keep it, square x square. X would change it to square root of a square minus y square and then cos theta. And then on top dx change into square root of a square minus y square minus sin theta d theta. Now we do it again, square root of a square minus y square minus, in bracket, a square minus y square multiplied by cos theta, cos square theta. If I resolve this, then a square root of a square minus y square would come out, and it would remain as square root of 1 minus cos square theta. That would resolve into sin theta. So we have now double integration square root of a square minus y square sin theta, again a square root of a square minus y square minus sin theta d theta and dy. Sin theta, sin square theta. A square root of a square minus y square would into square root of a square minus y square would become a square minus y square. Being this constant, I can keep outside. Outside is square root of a square minus y square, double integration, and then minus I can keep outside. Minus square root of a square minus y square. Sin square theta d theta. Integration of sin square theta is x by 2. X by 2, I believe it is plus sin 2x divided by 4. X by 2 plus sin 2x divided by 4. Now, if that is the case, that we had taken a radius like this, where angle is theta, and this is square root of a square minus y square, and it moves like this, then when x is minus a, then it makes angle pi. Being this is theta, pi to 0. X is minus a to a, then 0 to 0. Then 0 to 0 minus a to a, The theta is pi to 0. So x by 2 integration of sine square theta is x by 2 plus sine 2x by 4 pi to 0. 0 full washed out. Pi then sine 2x is 0 again. X by 2 would remain. So x by 2 means minus pi by 2. Minus pi by 2. That is the integral. Minus and minus I had kept outside, gone. So plus pi by 2. So integration is pi by 2 a square minus y square dy. So pi by 2 I can keep outside. Now the code that will come into picture to get executed is a square minus y square dy. Okay, first limit minus a to a transformed into pi to 0. Now other limit is minus a to a and then a square minus y square dy. That will resolve into a square y minus y to the power 3 by 3. A square minus y square integration along dy is a square y minus y to the power 3 by 3 minus a to a. If I set it a, then it becomes a to the power 3 minus a to the power 3 by 3. That is 2a to the power 3 by 3. That is the integration. 2a to the power 3 by 3. Then minus a to a, I have to substitute. A resolves into 2a to the power 3 by 3. Minus a would bring it same, it would double it. So it is 4a to the power 3 by 3 outside pi by 2. So all along 2 pi a to the power 3 by 3. But whatever we did, this is origin and this is x-axis. It's very heavy. Okay, so if this is x-axis, and this is the sphere, so where x-axis is piercing at the equatorial, then this is minus a, this is plus a, this is minus a, this is plus a, centered at the origin. If that is the case, then whatever the z value we have taken a square root of a square minus x square minus y square. So this is xy plane. This is x-axis, this is y-axis. This is xy plane. It is half in the xy plane, top hemisphere, bottom hemisphere. So top hemisphere, we calculated the volume is 2 pi a to the power 3 by 3. So net volume is 4 pi a to the power 3 by 3. I don't know what is the volume of a sphere. I personally don't know. I believe this would be the case 4 pi a to the power 3 by 3. If it is wrong, then I will see where it is wrong. Anyway, that is the case. We calculated volume of a sphere through full-fledged Cartesian coordinate system. At least I did not find it anywhere. This is our formula. Can we try this volume? In cylindrical coordinate system? That is the question. What is cylindrical coordinate system? Okay, do we really have a cylinder? Okay, this is more or less like a cylinder. This is more or less like a cylinder where bottom part is a circle. Bottom part is not a circle. I'll try another one. This is really a cylinder where bottom part is a circle. Bottom part is a circle and then it has a kind of vertical part. So bottom part, the dA small area is r d theta dr. Many times we have discussed it. r d theta dr. Like in Cartesian coordinate, the dA is dx dy. Here dA is r d theta dr. If this is the center, then this is the radius and this is arc. If I take a small area, then one side is arc and one side is radius of the small area. So the arc is r d theta, where radius is dr. If this is the small arc, then angle for the small r is d theta, and this is r, then small r is dr, then area is r d theta dr. So r d theta dr is the dA, and this is the height. What is the function? That is, function is z square, function of a, oh sorry, okay, this is cylindrical coordinate system, but at the end we have to find the volume. At the end we have to find volume of this sphere. So volume of this sphere we have found is nothing but z dA fxy, or z dA, z height dxy plane. So what is height? If I take this and cut it at the equatorial, then it is a circle with radius is a, that is the radius of a sphere. At height z, if I make another cut, then there is another circle where radius is any r. R is variable. If this height is 0, then r is a, that is the radius of the sphere. If this height is z, then this r is r. If this height z is become a, then radius is 0. If that is the case, then we come into situation like, if this is the we come to a situation like, if this is the, I'm talking about the base. The base means the equatorial, I cut the sphere into two parts. The middle portion I am talking about, that is xy plane. So sphere is centered at the origin. If it is centered at the origin, then if I talk about that circle, if this is the center, then this is radius. Okay, radius is a. Okay, now we talk that we talk that if it is centered at the origin, then at the center it xy plane. If I take z value, and cut again, then that circle has a radius r. So if that is the case, then if this is origin, and this is a, then at height z I made a cut, then this is small radius r. If this is small radius r, then this is height z. If that is the case, then this hypotenuse is a, because a is radius of the sphere. So if I have a sphere and it is centered, then any moment the radius is a. If this is a and this is height z, then this is r. If this height is full a, then this radius becomes 0. If this height is fully 0, then this radius becomes a. So we are in some condition where this height is z and radius r, and this full hypotenuse is a. Then z equal to a square minus r square. Height equal to hypotenuse by base, or base equal to hypotenuse by height, whatever it is. So z equal to square root of a square minus r square. Now we have volume as z dA, one integration. Z, that is the height. So z is square root of a square minus r square. Square root of a square minus r square. Okay, and then dA is r dr r d theta dr. That is the dA we talked about. So r square root of a square minus r square dr d theta. That is the volume. So where r is from 0 to a and theta is 0 to 2 pi. If that is the case, then integration of r square root of a square minus r square would be minus 1 by 3 a square minus r square to the power 3 by 2. I believe so. A square minus r square to the power 3 by 2. If I differentiate it, it's become 3 by 2 a square minus r square to the power 1 by 2 minus 2r. 2 cut down and it becomes minus r. 3 minus r. 3 minus r a square minus r square to the power 1 by 2. So the integration of r square root of a square minus r square is minus 1 by 3 a square minus r square to the power 3 by 2. Okay, so that would be its integration. So limit is 0 to a. 0 to a. If I put a in a square minus r square, where r is a, it is full 0. If I put 0, that is lower limit, then minus sign would go out. Okay, so we have 1 by 3 and then a square minus r square, r is 0, a square to the power 3 by 2, a to the power 3, a to the power 3 by 3, a to the power 3 by 3. The d theta is theta 0 to 2 pi. Okay, so d theta, so dA means if this is cylinder, then this is the bottom one. dA, we are taking this surface xy plane. Theta would go full 2 pi. So and radius would go origin to full a. So theta 2 pi. So we have now 2 pi a to the power 3 by 3. Okay, same as what did earlier, we have taken z from the, if this is xy plane at the equatorial, we have taken z from the xy plane. So downward, top hemisphere we talked about, bottom hemisphere we did not talk about. So it is congruent, it is same. So now the volume of this sphere would be double of what we have calculated. We have calculated 2 by 3 pi a to the power 3. So volume is 4 pi a to the power 3 by 3. 4 pi a to the power 3 by 3 is the volume. So this is through uh, cylindrical coordinate system. So we calculated through Cartesian coordinate system, through cylindrical coordinate. What about mind-blowing a spherical coordinate system? I thought I would finish it, but I believe it is too long. We will calculate it and it is thrilling. Calculating the volume of a sphere purely in a spherical coordinate system is something that is very thrilling. So anyway, we will talk about.